Welcome Alexander Schröder. He is a scientist at the Fraunhofer Institute for Chemical Technology ICT in Finstal. His research area includes the development and optimization of modern drive systems. Welcome also Andreas Schader. He is responsible for the coordination of regulatory and standardization activities in the global product management of the Drive Products division at ABB Motion. Throughout Europe, many electric motors for pumps, fans and compressors are designed to operate at a constant speed.
So on behalf of CMIP, that's the European Community of Manufacturers of Electric Motors and Power Electronics, we at Fraunhofer ICT wrote 2 studies. The first study is about the task if applications with variable load points can save energy when they operate with variable speed. And the second study is about the task if applications that operate at a constant load point benefit from smaller units with variable speed compared to bigger units with fixed speed.
So in the Fraunhofer study, it was concluded that in 2021, 60% of the total energy consumed in Europe goes via electric motors. Now, if you know that basically 2/3 of these motors are driven in applications like fan, pumps and compressors, and it's as a widely known fact, basically VSDs offer huge energy saving potentials, for us as manufacturers of those devices, it was of significant interest to quantify the energy saving potentials for these applications.
For the first study, units that operate at a variable load point can save up to 70% energy compared to fixed speed. And for units that operate at a constant load point, savings from 5 to 10% of energy are possible if smaller units with variable speed are used compared to bigger units with fixed speed, but these smaller units are closer to the desired operation point and are less oversized.
No, the results of the first studies were actually no surprise for us. We are basically selling variable speed drives since 50 years on the argument of energy saving in variable flow applications. The tremendous amount of 121 terawatt-hour saving potential was what really surprised us, and this really re-emphasizes that we have to consequently use variable speed drives in these applications. The paradigm shift, on the other hand, was the results of the second studies, where so far the industry oftentimes believed that there is no saving potential by applying a VSD to a constant flow application. And basically, this myth is now busted by the study.
So at this point, we're not talking about kilowatt hours anymore. So the savings are in the range of terawatt hours. The savings are 140 terawatt hours per year in Europe. And you see 60% of the electricity goes into electric motors and the half of it goes into pump, fan and compressor applications. Some of them already run with variable speed, for example, modern heat pumps, but there are remaining applications with less share of VSD, and the saving potential from these applications is around 140 terawatt hours per year. Yes, it's a lot. So this 140 terawatt hours are 5% of the energy consumption in Europe. And that's more than the Netherlands produce electricity energy in 1 year. And now if you transfer them into carbon dioxide emissions with the European electricity mix, you see that 38 million tons of carbon dioxide could be saved with this 140 terawatt hours. And now if you're looking at the emission goals of Europe, we want to get climate neutral until 2040. these savings could contribute a lot to achieve this goal. And the best is that this technology is already available and it only has to be used consequently.
So, by applying variable speed drives to electric motors, you're able to precisely control the torque and speed of the motor. Thus, you are able to precisely lower your operation point to the requested demand in part load operations. This is also where the biggest saving potentials can be realized. On the other hand, if you run with a constant speed application, you are then also able to precisely control the speed to the desired operation point. Thus, you are able to avoid over-dimensionings in those systems.
As Fraunhofer ICT, we want to keep the German and European industry competitive by providing new information and data with applied research, for example with these studies. For the company, you have to know your load profile and your application, and then by knowing the costs of energy and the cost for the frequency inverter, you can calculate and size the optimal system. As Fraunhofer, we only provide the technical facts.
Okay, and that's basically when we as ABB step in. Since now 50 years, we are selling variable speed drives and energy efficient motors. And we will talk to the customer, analyze his system, analyze his requirements, and then we'll also calculate for him on how fast he gets his return of investments. Taking into account also available governmental grants and loans, you basically end up in return of investment times of less than 3 years.